What's up, my people? Oroluwa here again today. In today's class, I'm right here with you physically, and we are going to be learning together some concepts on limits. So, in today's class, what I'm going to be doing is that I'll run a quick revision on the idea of limits. Then we are going to solve some questions that will make limits simple to you. So, I'm going to advise and admonish you to stay true to this video and try as much as possible not to be disturbed. And I promise that you have a lot to learn today. Without wasting your time, let's get right into what we are here for today. Limits, limit of functions. The entire idea of limits runs on the idea of functions, which is why we have tried to lay the foundation before now. Now, if you see an expression that looks like this, that is y is equal to f of x, there's a lot to pick from this expression. And what are the things to pick? Whenever you see y stands for the dependent variable. We say it is the dependent variable. And this x stands for the independent variable. Now, what's the difference between the two? Now, this y is dependent on x. Now, this f is the rule that is at work in those two variables. I mean, you've seen stuff like this before. That is a function that relates a to b, set a to b, such that you have x to be elements of a and you have y to be elements of b. That's the idea of function, such that you have a variable depending on another variable. Example, if I write a function y to be equal to 2x minus 5, this is an explicit function that clearly illustrates what we wrote here. Now, for every values of x that you input into this y, or for every values of x you put here, it gives a different value for y. Now, when x, of course, we know that y is equal to 2x minus 5, and that is as well a function of x. That is, y can be written as f of x. In a case where x is 1, that is, in a case where x is 1, let's say y1, f of 1, what you have there is 2 into brackets 1 minus 5, and that is minus 3. Now, if I change the value of x, you observe that y will have a different value. So y depends on x. Y is the dependent variable and x is the independent variable. X doesn't need y to change, but for every change in x, there is an effect on y. And that is why we say y is the dependent variable and x is the independent variable. Now, knowing the idea of dependent and independent variable and how that idea works is the beginning of the knowledge of the idea of limits of functions. Now, what is limits of functions? Now, you know I wrote y to be equal to f of x, and I said this is where it all starts. The idea of limits is that as the independent variable x is approaching a point, the function is approaching its limit. F of x is approaching its limit. Example, let me make this very simple for you. If I write y is equal to, let's say, x squared. Now, you know that as x is approaching the value of 2, either from the left or from the right, we are still going to talk about that, or maybe perhaps you should know that by now. Now, as x is approaching 2, either from the left or from the right, I mean, if you have a number line, I'm sure you know what number line is, and you have, let's say, 1 here and 0 here. Now, if x is approaching 2 from either the left or from the right, you agree with me that this particular y will be approaching 4. That is the idea of limit. Limit works with the idea that as the independent variable is approaching a point, the dependent variable is approaching its limit. So we say as x is approaching a, y or f of x is approaching l. And we write it like this. We say limit as x approaches a, of f of x is equal to L. Of course, for the limit of a function to exist, we have that the left hand limit and the right hand limit must both exist and be equal. And this particular limit must be a real number. The limit must be a real number. These are the core idea of limits. So, but without wasting time, with this little thing that you know, we can solve problems under the idea of limits of functions. So, I'm going to be solving 5 questions for you that you should know how to solve as an MTH 102 student. And I want to admonish you, and I also want to plead with you to share this video with all your mates so that they can learn 1 or 2 things from what we are learning or from what we are doing. Thank you. Now, there are about 4 classes of questions or 5 classes of questions that you can see in limits. The first one is what I call the factorizable fractions. Now, that is, you see a fraction and the fraction can be factorized. Either the numerator or the denominator can be factorized. The second one is sort. They will ask you to evaluate the limits of problems that have roots. Now, those ones have a different approach to them, which is rationalization. Another set of questions that you can see, or another class or classes of questions that you can see, are questions that have sign or cos inside them, which will demand you to use what we call squeeze theorem. That's the third class. Another class of function or limits questions that you will see are those that will give you indeterminate forms. Any of the indeterminate forms, you have about 7 indeterminate forms, and they will give you any of the indeterminate forms. And for every problem that gives you any of the indeterminate forms, you know you can always apply L'Hopital's rule. So we are going to be solving problems on these classes of limits. So let's start with this very question. Now, if you can solve this problem, then I am sure that you already have about 20% knowledge of limits of function. Now, this question is asking us to evaluate the limit as x approaches 2 of x minus 2 all divided by x squared minus 4. I told you the other time that limit works with approach. Now, I do tell my students the difference between a very good student and an average student is the ability to pay attention to details. Now, limit works with approach, not equality, in the sense that all we need or all we check is that as the independent variable is approaching a point, what is happening to the dependent variable? What is the dependent variable approaching? Now, if you look at this problem critically, and I ask you, what is happening at the point 2 itself? That is, if I drop x being 2 into this fraction, what will I get? Now, if you drop 2 into this fraction, the numerator will give you 0. The denominator as well will give you 0. And you know what happens when the denominator of a fraction is 0? We say the fraction is undefined. However, because limit works with approach, so it means that we are saying what is happening when x is around the point 2. Now, when x is around point 2, that gives us the freedom to simplify this fraction. And that implies that what we have here is equal to the limit as x approaches 2 of x minus 2 all divided by what we have at the denominator is a difference of 2 squares. And that means that it can be expressed as x minus 2 multiplied by x plus 2. Now, you can see that x minus 2 will cancel out x minus 2. And that implies that what we have is limit as x approaches 2 of 1 over x plus 2, which is then the same thing as 1 over 4. And that is the answer. So that means that as x is approaching 2 of this function, the function itself is approaching 1 over 4. Now, that is the solution to this problem. Let's consider another problem. All right, this question is asking us to evaluate the limit as x approaches 1 from the right. That's the meaning of this plus. Now, the plus has nothing to do with the 1. The plus doesn't mean that the 1 is maybe positive or negative. I mean, you know that 1 is positive. However, this means that x is approaching 1 from the right of x plus 2 all divided by x squared plus 2x minus 3. Now, how do we solve questions like this. Now, the first thing that should come to your mind, obviously, when you see something like this, is to try to simplify. That is, simplify or check if the denominator can be factorized. And if you check that, can it be factorized? If you check it, you have limit as x approaches 1 from the right of x plus 2, all divided by factorizing this will give you, we have minus 3, and the factors of minus 3 that will give you 2 on addition and minus 3 on multiplication is 3 and minus 1, plus 3 and minus 1. So if you do that, plus 3 and minus 1, what you have will be x plus 3 multiplying x minus 1. I mean, if you open this bracket as x squared minus x plus 3x, then minus 3. So that's this. Now, on factorizing the denominator, this is what we have. But from what you can see, the numerator cannot divide the denominator in this case. So that means that they are not factors. We don't have any factors at both the numerator and the denominator. So what's the next thing that you should do? Now, if you look at the fraction itself, if you substitute the values of 1 into the numerator and the denominator, you observe one thing. And what you observe is that at the numerator, you will have a value that is close to 3. I mean, we know that x plus 2, at the point where x is approaching 1, x plus 2 is approaching 3. Then at the denominator, if you insert 1 or values approaching 1 from the right into the denominator, you will get 0. However, the question is, what kind of 0 will you get here? Because x is approaching 1 from the right, it tells us one thing in the idea of left and right hand limit. Anytime x is approaching a point from the right, it means that x is greater than that point. Now, what does that tell us here? It tells us that anything you put into this x squared plus 2x will be seemingly greater than minus 3. Although we know that x squared plus 2x, see, this is what I'm saying. We know that x squared plus 2x will be approaching 3. X squared plus 2x will be approaching 3 as x is approaching 1 from the right. We know that for sure. So, but we know that the kind of 0 we have here is considered to be a positive 0, if that makes any sense to you. So, to just let us know that what we have here is a positive infinity. What we have here is a positive infinity. Now, in a case where this x is approaching 1 from the left, it will be 3 all divided by a kind of 0 that is close to the negative 0. Now, that will give you negative infinity. Do you understand? So, you just need a little bit of analytical skill to be able to, tell when something is something. Do you understand? And you won't have any problem at all. So, the solution to this question is positive infinity. Of course, somebody is saying, but anything divided by 0 is undefined. Well, infinity itself does not have definition. So, in a case where you have constants divided by 0, you can take it to be infinity. If you have constant over 0, you can take it to be infinity. Now, if this 0 is close to the positive 0, maybe you have 0.0000 something, then of course you know that constants divided by such will approach positive infinity. And if this is close to the 0 from the left, that is minus 0.0000 something, then you know that will be negative infinity. Now, you know the problem we solved is when x is approaching 1 from the right. And I've also analyzed what will happen if x is approaching 1 from the left. Now, the question is, what do you think will happen if x is just approaching 1? Now, if x is just approaching 1, then that demands critical analysis. What will happen is that from the right, since we know that from the right, that is, when x is approaching 1 from the right, you have positive infinity. The fraction gets really large positively, and when x is approaching 1 from the left, the fraction gets infinitely very small, that is negative infinity. Now, what will happen when x is approaching 1? is that the limit does not exist, because in this case the right hand limit is giving you positive infinity, the left hand limit is giving you negative infinity, and for the limit of a function to exist, you know that the left and the right hand limits must exist and be equal. Do you understand? So in this case they are not equal. One is giving positive infinity, the other is giving negative infinity, and that means that if the limit is if x is approaching 1, then the result of this we write does not exist. Simple as ABC. That's what we write if x is approaching 1. I hope you understand that. Now let's move to another question. I believe you've been enjoying the video, and the information reaching me is that somebody watching this video is yet to subscribe to this channel. Why? So this content is made free for you. The least you can do to support us is to subscribe to the channel, like the video, and share this video to as many of your friends and mates, classmates as possible. They have something to learn too. Let's be good people, and it all starts here. Keep enjoying the class. All right, this is another different form of question entirely. Now, the first thing that is obvious to me and you is that you can see square root, and like I said, for every question you see in limits, there's a special approach to them, and that's why you have to solve as many problems as possible under limit of functions. Now, since we can see square root here, it means we need one approach. And what is the approach? It is the approach of rationalization. So the first thing that comes to mind is rationalize. Now, what we have here, that is the limit as h approaches 0, then you have the square root of x plus h minus the square root of x, all divided by h, multiplied by the square root of x plus h plus 1, divided by the square root of x plus h plus square root of x. Now, if you open that, if you deal with that, you have the limit as h approaches 0. Now, this multiplied by this is x plus h. You know that if you multiply this with this and you multiply this with this, they will cancel out. Then there will be minus x, that is square root of h multiplied by square root of h is x with the sign negative. Then divided by h multiplied by the square root of x plus h plus the square root of x. Now, what we have at the numerator, you have x minus x. So this will cancel this out. And you are left with what we have there is limit as h approaches 0 of h over h into bracket square root of x plus h plus the square root of x. Now h will cancel h, and you are left with limits as h approaches 0 of 1 over square root of x plus h plus the square root of x. Now in this case, if you insert h being 0, you know h is approaching 0. What you have will be 1 divided by the square root of x plus the square root of x, which is the same thing as 1 divided by 2 root x. Now if you rationalize that, that is multiply both the numerator and the denominator by root x, what you have will be root x divided by 2x, and that is the answer to this limit problem. Anytime you have square root, the first thing that should come to your mind is rationalization. Now I'm going to give you a question that looks like this, and I will expect you to solve it using the knowledge that I have gained so far. Let's go. So guys, look at the question on the board, pause this video and solve this question. Tell me your answer. Don't worry, let's give it for you. Yeah, solve it. Alright, so I want to believe you've solved it and you have your solution with you. So let's solve it together, guys. We have the limit as x approaches 1 of x minus 1 divided by the square root of x squared plus 3 minus 2. So what we have here is limit as x approaches 1 of x minus 1 divided by the square root of x squared plus 3 minus 2. Of course, like we said, rationalization, since you can see square root. Now, what you observe if you insert 1 directly into this function is that the numerator will give you 0. The denominator as well will give you 0. Of course, that will be the square root of 1 plus 3, which is square root of 4, and the square root of 4 is 2, and that will be 2 minus 2, that's 0. So you have 0 over 0, which is an indeterminate form. We are still going to get there. But because we've not considered indeterminate forms, that's why I don't want to bore you out with that. So let's just do well to rationalize directly. So multiplied by the square root of x squared plus 3 plus 2 divided by the square root of x squared plus 3 plus 2. Now, what you have is the limits as x approaches 1 of x minus 1 multiplied by the square root of x squared plus 3 plus 2. You close the bracket, then all divided by, if you open these brackets, you have x squared plus 3, then minus 2. Minus 4. That's minus 2 times plus 2, so that's minus 4. You close the bracket. Now, from here, this is the same thing as limit as x approaches 1 of x minus 1 multiplied by the square root of x squared plus 3 plus 2, close the brackets, all divided by x squared minus 1. Now, x squared minus 1, as you know, is a difference of two squares. You have x squared to be a square and you have 1 to be a square as well. And this x squared minus 1 is the same thing as x plus 1 multiplied by x minus 1. So let's come here. What we have there is then the same thing as the limit as x approaches 1 of x minus 1 multiplied by the square root of x squared plus 3 plus 2, all divided by x plus 1 multiplied by x minus 1. Now, x minus 1 will cancel out the x minus 1 at the numerator. So you are left with limit as x approaches 1 of the square root of x squared plus 3 plus 2 divided by x plus 1. Now, if you insert 1 into the numerator and the denominator, you will have the square root of 4 plus 2 all divided by 2, which is the same thing. Of course, you know that the square root of 4 is 2. So that's 4 over 2, which is the same thing as 2, guys. And that is the answer. Alright, the next question is asking us to evaluate the limit as x approaches positive infinity of 3 raised power x minus 3 raised power minus x, all divided by 3 raised power x plus 3 raised power minus x. So let's do a little bit of quick analysis. Now, one thing we know is that as x is approaching positive infinity, 3 raised power x will be approaching positive infinity as well. You know, that will be 3 raised power infinity, positive infinity. And 3 raised power positive infinity is infinity. Now, as x is approaching positive infinity, 3 raised power minus x will be approaching 3 raised power, of course, positive infinity, negative infinity. And that's the same thing as 1 over 3 raised power infinity, which is actually 0. That's 1 over infinity, that's 0. So, as x is approaching positive infinity, this guy is approaching infinity, while this one is approaching 0. In the same vein, this is approaching infinity, while this one is approaching 0 as well. So, it means that we want to find a way to simplify out 3 raised power x, which is very possible. So, how do we go about simplifying x? How do we go about simplifying 3 raised power x rather? That is bringing out 3 raised power x such that all that you have left will be 3 raised power minus x. Now, follow me. So, like I said, we want to find a way to simplify our 3 raised power x. So what we have is limits as x approaches positive infinity. If I bring out 3 raised power x in the numerator, I will have into brackets 1 minus 3 raised power minus 2x. I mean, if you use law of indices to open the brackets, that will be 3 raised power x, then minus 3 raised power x minus 2x, which is the same thing as 3 raised power minus x. So all divided by 3 raised power x into bracket 1 plus 3 raised power minus 2x. Now, what we have here and what we have here are the same thing, except that we factorized out one of the terms. Now, you know that this will cancel this out. It is common to both the numerator and the denominator. So in this case, you are left with limits as x approaches infinity, that's positive infinity, of 1 minus 3 raised power minus 2x, all divided by 1 plus 3 raised power minus 2x. Now, if you examine what is happening here, that is, as x is approaching positive infinity, you agree with me that 3 raised power minus 2x will be approaching 3 raised power minus infinity. And that's the same thing as 0. That will be 1 over infinity, which is 0. Now, that means that what we have there, if we insert x approaching positive infinity, will be 1 minus 0, all divided by 1 plus 0, which is 1 over 1, and the answer is 1. So, I hope you paid attention to the analysis that we did, and that is the solution. Meet you in the next question. If you see a problem like this, a problem that asks you to evaluate limits, and then you see sine or cos of angles like this, or you see cos or sine like this, the first thing that should come to your mind is squeeze theorem. You don't understand. Squeeze theorem. Now the question is, what is squeeze theorem? Now, squeeze theorem tells us, it's a very simple theorem, and it's a theorem that tells us that if you have a function f of x being squeezed in between two other functions, so let's say you have a function h of x and you have another function g of x. Now, if f of x is squeezed in between h of x and g of x like this, if you evaluate the limits as x is approaching a of h of x, and let's say you get a limit L, and you evaluate the limits as x is approaching a of g of x, and you also get the same L, then squeeze theorem is saying that the limits as x approaches a of f of x, the guy at the middle, will surely be L. Simple as ABC. That is, if a function f of x is squeezed in between h of x and g of x, if you evaluate the limit as x approaches a of this guy, and you get a certain limit, you evaluate the limit as x approaches a of g of x, and you get the same limit, then it implies that the limit as x approaches a of f of x, the guy at the middle, will be the same limit. In short, in real life, what squeeze theorem is saying is that show me your friend, and I'll tell you who you are. The same statement you find in English. So now you've seen that mathematics is a general language. It's more like communicating. Do you understand? So this is the idea of squeeze theorem, and let us apply it to solve. Let's apply it to solve this problem. The limit as x approaches 0 of x squared sine 1 over x. So how do you go about it? We know that the sine of an angle from the idea of trigonometry cannot be greater than 1, and at the same time it can be less than minus 1. The sine of any angle is cut in between minus 1 and 1 like this. In the same manner, we know that the sine of 1 over x cannot be greater than 1, and at the same time cannot be less than minus 1 for any value of 1 over x that you can have there. So the next thing I want to do, and whenever you are using the idea of squeeze theorem, you must always look at your question in order to know how to go about it. The next thing we want to do now is to multiply all through, multiply all through with x squared, or by x squared. Multiply all through by x squared. If I multiply all through by x squared, I will have minus x squared to be less or equal to x squared sine 1 over x, and that will be less or equal to x squared. Now, if I evaluate the limits as x approaches 0 of this guy, the limits as x approaches 0 of minus x squared, we know that the result is 0. If I evaluate the limits as x approaches 0 of the x squared, the positive x squared at the right hand side, we also know that it will be 0. So that tells us, therefore, that implies that the limit as x approaches 0 of x squared sine 1 over x, the guy at the middle, will be equal to 0 as well. Simple as ABC. So using the idea of squeeze theorem, we know that the result of this limit is 0. Now, I know that you have been learning free of charge for some minutes now, and I'm telling you that it is not always so. What does that mean? It means that there's still a lot to learn, and you just have to be there. Like, you must not miss it. And that is why you have to register with us at Dream Tutors. Reach out to me at 0903-624-6728. This is my WhatsApp number. Make sure you reach out to me to register. The next video I'll be uploading is for private students, and it will be a video for L'Hopital's rule, where we are going to be addressing all the indeterminate forms and how to solve them using L'Hopital's rule and every other rules that you can think of, like Taylor expansion series and other ideas. You must not miss the next video, and it will be my pleasure to have you as my student. So message us today. The tutorial fee is very affordable. In fact, too affordable for what there's a lot to learn. There's a lot to gain at Dream Tutors, and I don't need to be boasting about our results. You must have heard about them, and if you have not heard about them, message me. I will send results to you. Testimony in our water. Join us today, and you will forever be grateful you did. I'll see you another time. Thank you for staying with me all through. Bye for now.